Hey guys, this is us going through the chapter 13 test review or quiz review. It's a test, 100 points as per usual, and just going to walk you through beginning to end and make sure that if there's any questions you guys come in and get them asked. So the very first thing you're going to be given is be asked to find the sine, cosine, tangent, cosecant, secant, and cotangent ratios using O, A, and H. You know, this is that SOHCAHTOA, so what's your sine, what does a crow say, ka, 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 and then the tangent, don't stub your toa. And so all you're doing here is putting O over H, A over H, O over A, and then reciprocating each of these to H over O, H over A, and A over O. We also have those definitions in terms of X, Y, and R. Here I say to use O, A, and H, so we're trying to be very clear about what I want you to do. Given that information, we're going to work with this right triangle here to find the sine, the cosine, the tangent. From theta's perspective, this would be our opposite. This is our hypotenuse, and we need to find our adjacent. You're going to have to use Pythagorean's theorem. Remember that in a squared plus b squared equals c squared, the c must be the hypotenuse. So this would be like an a squared plus 4 squared equals 5 squared. Because it's a squared plus 4 squared, we're going to minus the 4 squared. And that gives me the a squared equals, throw that in the calculator, 25 minus 16 is 9. Square root that, we get 3. A equals 3. Now it's entirely possible that on the test question you get a square root, like square root of 11 or square root of 13, something that doesn't reduce. I don't want a decimal equivalent here. I want the root if it's a root. That doesn't simplify. Here the sine is the opposite, which would be 4 over the hypotenuse of 5. And the cosecant is the reciprocal, 5 over 4. Cosine is the adjacent, 3 over the hypotenuse 5. And secant is the reciprocal. Tangent is opposite, 4 over adjacent 3. And 3 over 4. Remember that if you end up with something like root 2 over 7, that's okay. But when you go to give me the flip and you get 7 over root 2, you have to pull the root out of the denominator and put it up. And so this would be something like 7 root 2 over 2. You need to remember to do that if you have a square root. There's no guarantees. You might end up like this problem with just whole numbers. Question number 3 says, you know, what is theta? I have this triangle. I have all this information. What the heck is theta? And so if we just take one of our simple ones like the sine, we say that the sine of theta is 4 over 5. Well, if I want to get theta alone, I'm going to use a sine inverse. So if I apply the sine inverse to 4/5, then theta should equal, and I'm going to have to use a calculator to do this. When I turn it on, I make sure my mode is degrees, which mine is, and I'm going to press second sine 4 divided by 5. And that gives us a 53.1 degree angle. So theta is 53.1 degrees. Yes, you should be able to pick. And if you had chosen to do cosine or tangent, you'd use those inverses and get the exact same answer. We want to convert 285 to radians. Anytime we want to convert degrees to radians, all we have to do is divide by 180 and put a pi next to it. I'm going to use my calculator to get a nice clean number. So 285 divided by 180. Whoops, I missed my 0. Let's try that again. 285 divided by 180. I want that as a fraction though, so math, frac, enter. It's 19 over 12. So my answer would be 19 pi over 12. Well, I want to convert 4 pi over 9 to degrees, so instead of timesing by pi over 180, I'm going to use 180 over pi. That'll cancel the pi's. And then I'm going to put this in the calculator just as 4 divided by 9 times 180. And if I press enter, I get 80 degrees. So this comes out as 80 degrees. Okay. At this point, we're going to have to start living on the unit circle a little bit more. I say to evaluate these without the decimals. So I'm going to click back and forth with my unit circle here, but I'm looking for negative pi over 3. Now keep in mind, The sine, when we use the circle, is the y value. The cosine is the x value, and the tangent is the y over the x. So on negative pi over 3, all I need to do is find the y value. If I go to my unit circle, clean it up a little bit here. If I go to my unit circle, negative pi over 3, okay, well, pi over 3 is 60 degrees. If I went negative 60 degrees, that would put me down here at 300. So my ordered pair is 1/2 comma negative root 3 over 2. Let's take that back to our test review. The ordered pair here would be 1/2 comma negative root 3 over 2. Well, the y value is negative root 3 over 2. So there's my sine value. If you put the sine of negative 60 in your calculator, it would give you a decimal, which I don't want. I want the actual answer that comes from the circle. Well, now I'm doing the cosine of 150. I'll go to my unit circle, I find 150, which is right here. Here's my x and y. It's negative root 3 over 2 comma 1/2. I'm going to go back to the test review. Negative root 3 over 2 comma 1/2. Turns out here the x coordinate is also negative root 3 over 2. And that would be my cosine of 150. Last one is the tangent of 4 pi over 3. Well, let's go find 4 pi over 3. 4 pi over 3 is down here. There's my x and y. My y is the root 3 over 2 and x is the 1/2. They're both negative. So my ordered pair here is negative 1/2 comma negative root 3 over 2. I'm going to look over at my circle real quick and just make sure when I switched from the other screen, I want to make sure I don't make any mistakes. So that looks good. So now I'm going to stick my y, which is negative root 3 over 2 over negative 1 over 2. Whenever I'm dividing fractions like this, we're going to choose to multiply by the reciprocal, which would be negative 2 over 1. That gets rid of the denominator. A couple things. The 2 will always reduce with the 2, and a negative with a negative, those cancel, leaving me with a positive root 3. It is over a 1, but I don't really need the 1, so you could just have root 3 as your answer. Again, we're pulling that information from the circle. Still using the circle, we're going to answer reverse. Okay, we want to find when is the sine equal to 1/2. There should be multiple answers for some of these. Some might not have multiple answers, but we'll go from there. So we're looking for the sine, which is the y value, to be 1/2. Well, if we look, right there's a y value of 1/2. And remember, sines always go across the circle, and there's another one. So I've got 30 and 150 degrees. So for degrees, I would say, oh, I got to change my thing here. For degrees, I would say 30 degrees and 150 degrees. Looking at my circle, that's the same as pi over 6 and 5 pi over 6. The next one, cosine of theta equals negative 1. That's the x equaling negative 1. Well, if I go back over here to my unit circle, I'm looking for the x to be negative 1. There's a spot right here where x is negative 1. Cosine is supposed to move up and down to find our second answers. Well, there isn't another place where cosine is going to equal negative 1. You can look at all the ordered pairs. It never happens again. So my answer is only going to be 180 degrees and pi. Over here, we'll do 180 and pi. The last one is tangent equals root 3. Now, hopefully you took some time and you worked on your circle and you made it better by putting things like the tangents on there, but the fact that the tangent is root 3 tells me that my x and my y, remember this is y over x, my y and x, somebody's got to have a root 3 in the problem to begin with. So either I want root 3 over 2 over 1/2, root 3 over 2 over 1 over 2, or I want 1 over 2 over root 3 over 2. Well, if I flip and multiply each of these, I get 2 over 1. I get 2 over root 3. Over here, the 2's cancel. And I get root 3 over 1, which is just root 3. That's the answer that we're looking for our tangent to be. Over here, if I did it, the 2's would still cancel. I'd get 1 over root 3, which we know we have to pull the root up to get root 3 over 3. Not the answer we want. So what this tells me, okay, is that my y needs to be root 3 over 2 and my x needs to be 1/2. If I'd been looking for root 3 over 3, then I would have the opposite situation. So I need to go find a place on the circle where my y is root 3 over 2 and my x is 1/2. All right, so go to the circle. My y has to be root 3 over 2. That would be right here. My x is 1/2. So I like 60 degrees and pi over 3. Well, I could look over here too. This would work as well, except that because one of them's positive and one of them's negative, the tangent here will be negative. I don't like that. If you remember the tangent, it's always supposed to follow the diagonal. And that would put me back down here at 240 or 4 pi over 3, where I have the same y and x, but they're both negative, and both negative means they'll cancel. So that's going to put me at 60 degrees or 240 degrees, which is pi over 3 and 4 pi over 3. All right, so that's how we find all of those. Again, the tangent's the trickiest one, which is why if you have the answers for the 3 tangents at 30, at 45, and 60 already written on your circle, it's a lot easier because you don't really have to do any solving there. All right, last thing. I didn't give you the I didn't give it on this version of the test, but let's go ahead and write in the numbers and the letters that I gave you. A, B, and C. We've got a 12 here, an 8 here, and a 70 degrees here. All right, we're supposed to find all 3 sides, capital A, capital B, capital C, little a, little b, and little c. All right, so let's start off with capital C right here is 70 degrees. Okay, because the 12 is directly across from that C, that makes 12 be little c. And that 8 is directly across from big A, so that would make it little a. All right, so the first question we have to ask is, do we have a complete set? Meaning, do we have both of some letter? We have both C's, which means we can use the law of signs. And if you remember the law of signs, the sign of capital A over little a equals the sign of capital B over little b. Well, we can use that using our C information and the little bit of A information we have. I'm going to write over here the sign of the unknown, big A, over little a, 8, equals the sign of 70 over 12. Now to solve this, I need to get rid of this 8, so I'm going to times by 8, times by 8, and that'll cancel over here. Gives me the sign of A equals, and this can all go into my calculator, so let's get that calculator up. And we can type in, and again, make sure we're in degree mode, which I just checked a minute ago, sign of 70 divided by 12, and I want to multiply by 8. I get 0.626, roughly speaking. All right. Well, if I want to get A alone, I'm going to need to take the sine inverse. Anytime we're finding angles using trig, we're going to have to take the sine inverse or some sort of an inverse function. So I'm going to now take the sine inverse of, and I'm just going to select that previous answer. And I get 38.789. Let's round that out to 38.8 degrees. So capital A is going to be 38.8 degrees. If I want capital B, I'm going to subtract from 180. Anytime you're finding the last angle, it's a good practice to just take 180 minus your 70 minus, and I'm just going to count, well, let's not complicate it. Let's go 38.8. Okay? And that gives me 71.2 for my last angle. 71.2 degrees. So this is my biggest angle. This side, side B, should be bigger than 12. I can't use Pythagorean's theorem because I don't have a 90-degree angle. The only thing I can do is more law of sines. For this time I'm going to set up law of sines with the little letters on top because the thing I'm looking for is a little letter. So we'll set it up as little b over the sine of big B, which is 71.2, equals, let's do little c, 12 over the sine of 70. To get little b alone, I'm going to have to multiply this sine of 71 over. So I'm going to times by the sine of 71.2. That'll get rid of the sign down there. And then b will be alone. So I just need to put this in my calculator. 12 divided by the sine of 70, close my parentheses, times the sine of 71.2. And if we do that, we get 12.088, so we're going to round that to 12.1. All right, is it bigger than little c? Yeah. Is it a lot bigger? No. But we have all three sides, all three angles, and we move on to question 13. I know this video is starting to drag on a little bit, but we're close to being done. We've got A, B, C, with 15 over here, 17 over here, and our angle in the middle is 85 degrees. All right. So when we go to build our information, right, we got capital A is unknown, capital B is 85, and capital C is unknown. Little a is 17, little b is unknown, and little c is 15. Remember, they're directly across from the angles. That's how I know that little c is 15 and little a is 17. Because I don't have both a's, both b's, or both c's, I can't use law of sines. I'm stuck using law of cosines, which is fine, but remember, you want to always find the one that you're working on the angle for. Since we're working on angle B, we know that angle, we're going to use that version of the formula. That formula should look something like b squared equals a squared plus c squared minus 2ac cosine of big B. All right, we can plug all the information in and start to find b. b squared equals a, which is 17 squared, plus c, which is 15 squared, minus 2 times 17 times 15 times the cosine of big B, which is 85. Okay. I am such a big proponent of saying all of this can be evaluated at the same time. Because we don't have any unknowns over there, let's evaluate it in one big step. So this will be 17 squared plus
Mr. Welch.
just one. Sorry about that. Okay, let's get this all typed in. Plus 15 squared minus 2 times 17 times 15. I have a lot of students who will right here hit enter. Don't ever do that. There's still a multiplication of cosine. I'm going to put cosine 85. Now that I've got everything typed in, we can press enter. We get 469.55. So over here, 469.55 equals not b, it equals b squared. So to get b, I'm going to need to take the square root of that. And we take the square root of that answer. We get 21.7, we'll go with 21.7. And now I need to find capital A or capital C. I have both B's, so I can now use the law of sines if I want, make it a little bit simpler. Let's go after, well, it really won't matter, but I'm going to go after C. So now I've got the sine of big C over 15 equals the sine of 85 over 21.7. Here I'm going to multiply by 15 to get rid of that 15 down here. And I'll have the sine of big C equals some number that's going to come out of the calculator. So let's evaluate that. We'll start with the sine of 85 divided by 21.7 times 15. And we get 0.6886. 6886. And then we need to take a sine inverse in order to get that C alone. And so we'll take a sine inverse. And second sine of that answer is 43.5. So we'll go with 4 capital C, 43.5. To get capital A, we need to subtract all that from 180. So 180 minus 43.5 minus 85 is 51.5. 51.5 degrees. All right, last question is our bonus problem. We got A, B, C with 5 here, 10 here, and 12 here. And your job is to find the measure of angle A. The way we do that is the law of cosines, but the trick is that the thing we don't know will be way over here on the far end. So because I'm looking for angle A, I'm going to start with little a. Little a squared equals little b squared plus little c squared minus 2 times b times c cosine of big A. What's the formula I'm working with? Now I need to plug in some numbers. Little a is 10. We'll square that. It'll equal b, which is 12 squared, plus c, which is 5 squared, minus 2 times 12 times 5 times cosine of big A, which I don't know. This is what's really important. These two guys can be subtracted, but the rest of it can't. It's division, because the connection between the 5, the 12, the 2, and the cosine right there is multiplication. So what I'm going to do is I'm going to go ahead and subtract the 12 squared and subtract the 5 squared. And that'll get rid of those two. Let's go and see what the calculator has to say for us. 10 squared minus 12 squared minus 5 squared is negative 69 equals. Now all of this can be turned into a single number times my cosine of A, but it's important I recognize this is a multiplication, okay? So a negative, make sure we get a negative here, negative 2 times 12 times 5. That was what was there. That's negative 120. It's really important that we have it's negative. It should always come out negative. And it's multiplication. So the way I solve for cosine is by dividing by negative 120. Dividing by negative 120. So now the cosine of capital A, not A, but the cosine of A comes out to be 69 divided by 120. Those negatives are going to cancel. They won't always cancel. It just depends on that first number. But I get 0.575. 0.575. And to solve it, I need to take a cosine inverse. Cosine inverse. So I'm going to take the cosine inverse of that 0.575. Second cosine 0.575. I get 54.9 degrees. So capital A is 54.9 degrees. And we're done. Good luck, guys. We'll see you in class. Come ask your questions. And remember to get your unit circle ready to go.